Hi students, in this video we are going to see the linear programming graphical model. When do we apply linear programming graphical model? If there are multiple limiting factors, not one limiting factor. Last video we saw scenarios with one limiting factor, this one with more than one limiting factor. Let's have a look at this example. A company produces two products, alpha and beta, using the same resources. The following table provides the information regarding the production requirements and resource availability for the next month. Alpha, beta, usage, material, labor, demand. Alpha has unlimited demand. Since alpha's demand is unlimited, meaning what? You can sell any number of units. Then any availability will be limited for you, because you can sell unlimited alpha. So 6,000 kilogram, is it enough? No. Why not? Unlimited alpha can be sold. 12,000 hours of labor, is it enough? No. Why not? Unlimited alpha can be sold. So there are two limiting factors here. Material is limited, labor is also limited. Contribution per unit is given $3, $8. Following the procedure for the graphical solution, define the optimum production plan. Right. So graphical linear programming solution, that's a long method. There are certain steps we have to follow. I'll do the whole question, this one. Just follow the steps carefully. Then we will go to the exam questions and see how this has been tested in the exam. Right. So let me copy this data to my Word working sheet. Okay. Right. You can see there are two products, alpha, beta, and it's a graphical model. You know, in a graphical model we are going to have two axes, x-axis, y-axis. So first we have to define what we are going to take in x-axis, what we are going to take in y-axis, we have to define. So that's the step one, defining the variables. What are the variables we have to find here? Final answer I have to give. How many alpha we are going to manufacture, how many beta we are going to manufacture. This is what the final answer I'm trying to find. So the unknown variables here, number of units of alpha, and number of units of beta. These two are the unknown variables. So x and y will be that. Can I interchange? Can I take x as number of units of beta, y as number of units of alpha? No problem. Two products. This is why I said graphical model. In the last video I mentioned, if there are two products, we can go with graphical model. If there was a third product, I can't, because you can have only two axes. Third axis will make it three-dimensional. We can't do it. Done. Then step 2 is to define the objective function. Objective function means, why are we doing all this analysis? Can't we just start with some product, finish all the resources? No, we are doing this analysis to maximize profit. How do we maximize profit? By maximizing contribution. In the last video I explained fixed cost doesn't change when you change the product mix. So as long as I get highest contribution, that will give highest profit also. Maximize contribution. Let's write a formula for contribution. Contribution will be equal to, this product gives, alpha gives $3 contribution each. Contribution per unit, $3. How many units of alpha we are making? We don't know, but we call it x. So contribution from alpha is going to be 3x. Why 3x? 1 unit gives you $3, x number of units, like that. Similarly, y, the next product, beta, that gives you $8 contribution per unit, y number of units. 3x plus 8y, this is the contribution formula. Finally, when I get the answer for x and y, I can substitute them here to find the total contribution. Right now I don't know how much is x, how much is y, so let's call it 3x plus 8y. Objective finished. Then we go to constraints. Constraints. How do we analyze the constraints? One by one. Raw material. Material is the first constraint. Material. See, alpha uses 1.5 kilogram for every unit. There are X number of units. So, alpha's usage will be 1.5x. Beta uses 3 kilogram for every unit. How many units of beta? Y number of units. So, 3y. 1.5x plus 3y. This is the material usage. This must be less than or equal to the availability. How much is the available? 6,000. Look at this once again. This side what we have is the usage. This side what I have, how much is available. So, your usage can be less than 6,000. So, you are not fully utilizing the material, or it can be equal to 6,000. It cannot go beyond 6,000. This is how we show that less than or equal to 6,000. Next constraint, labor. Labor 4 hours. So, 4x plus 3y 12,000. 4x plus 3y less than or equal to 12,000. 12,000. Only two resources are there, but demand is also limited. Demand. Alpha it's unlimited, so alpha you can get any answer. Beta, your answer, number of units of beta should not be more than 1,500 because demand is 1,500. So, let's say demand of beta we have written by y, the letter y. This should be less than or equal to 1,500. Demand of y or demand of beta. X we don't have a limit, unlimited. Then there is one more condition, non-negativity. Remember, this is a mathematical model. So, answers can be considered in negative numbers also. But here we are talking about number of units. Number of units can never be negative. So, we have to say x and y should be greater or equal to 0. Greater than or equal to 0. 0 is okay. Positive is okay, but not negative. This is how we write the constraints. Material, labor are two resource constraints. Demand constraint is there for only one product. Non-negativity always applies. Always applies. Cool. Now we have to put this in graph. How do we show this in graph? First let me explain one by one and then we will see all of them together. This one, guys, look at this, 1.5x plus 3y, if it is equal 6,000, how do we show this in a graph? It's a straight line, linear graph. X and y, only power 1 is there, right? No squared, no square root. So, to draw a straight line, I need 2 points. Easy options, find how much is y when x is 0. If x is 0, this part will be 0. 1.5 into 0 is 0. So, you can forget about that. 3y equals 6,000. Y will be 2,000. This is 1 point. Check the other one, if y equals 0. Easy 2 points are these. If y is 0, then this will be 0. If this is 0, 1.5x equals 6,000. So, x will be 6,000 divided by 1.5. Take your calculator, 6,000 divided by 1.5. X will be 4,000. This is how you find the 2 points. Check when x is 0, how much is y. When y is 0, how much is x. Then on the graph, when x is 0, y is 2,000. When y is 0, x is 4,000. We will draw a straight line. This is if it is equal, straight line. But if it is less than or equal, what do we say? Any point under this graph will satisfy the inequality. Any point on the graph or under the graph. Why on the graph? Equal is there. So, on the graph. Why under the graph? Less than. Now tell me 4x plus 3y 12,000. How can I analyze this? 4x plus 3y 12,000. If x is 0, x is 0 means this part is 0. If this is 0, 3y is 12,000, y is 4,000, divide by 3. Then you check y is 0, how much is x? If y is 0, this part will be 0, then 4x is 12,000, divide by 4, x is 3,000. First one, x is 0, y is 4,000 here. Y is 0, x is 3,000. Draw a line. This also less than, can you see here? Less than. So, area under that. Demand, y 1500, this is where y is increasing. Can you see? This is where y is increasing. At 1500, draw a horizontal line. This says y cannot go beyond 1500. So, it has to be below 1500 or equal. Understand? Suppose if x had a condition, then we will draw a vertical line. If x is, let's say, less than 1000, at 1000 you draw a line and say less than that. But here we don't have x condition, so I am not drawing it. Non-negativity means, look here, x and y, we will only consider this part of the graph sheet, not here, not here, not here, because these three areas, at least one variable will be negative. If you come below here, these two areas y is negative, these two areas x is negative. So, this is the only area x and y are positive. This is how you analyze them in the graph, right? However, you know, your computer based exam, so far they don't have a facility to ask you drawing the graphs, right? But interpreting the graph is required. So, easy way to study that, when you are practicing this, you draw graphs on your book and learn. Then interpreting will be easy. If somebody knows how to draw the graph, they will easily interpret the graph as well. Okay, that's why I'm showing all this. Now the task is to put all of them together. X, y, 0, 0, 1000, 2000, 3000, 4000, 1000, 2000, 3000, 4000. First graph, first one, we had x is 0, y is 2000, and another one 4000. Okay, here. Had to be straight lines. I am not sure whether I can draw straight lines. Let's see. Not bad. Okay. This is for first one. First one was what? Material. Second one, x is 0, y is 4000, 3000. Okay, here 4000 and 3000. Okay, good. The technology helps us labor. Fourth one, 1500. 1500 here. Why that one is not helping? Anyway, 1500. I have drawn all the graphs. Last one is not a graph actually, just considering the first part, but this is drawn. These three graphs are drawn. After drawing all these three graphs, right, let me show you. Look at the area I am highlighting. Look at the area I am highlighting. Right, this yellow color highlighted area has a special feature. Can you guess what's a special feature? That is the area which satisfies all the conditions we discussed. All the conditions. What is the conditions? See, we drew this material line and we said your answer has to be below this line, below the material line. Okay, here below this. We drew the labor line and we said answer must be below the labor line. We drew the demand line and we said answer must be below the demand line. So, this is the only area that satisfies all the conditions. Imagine if I have gone to this area, look at the one I am highlighting. That is outside the demand condition. Won't work. If you take this area, this is outside the material line. This is outside the labor line. This is outside material and labor. So all these other areas at least breach one condition. But this yellow color shaded area satisfies all the conditions. So we call it feasible region or feasible area. What is the meaning of feasible area? Your production plan, the answer for X and Y should be within this yellow color area only. Let's give a name for that. O, A, B, C, D. O, A, B, C, D is the feasible region. Clear? Now, among the feasible region, how do we identify the optimum point, the best point? Because I need to find one point. How do we find that? Go back to the workings. Look at this contribution line, 3x plus 8y. Bring that contribution line. 3x plus 8y. This 3x plus 8y, make it equal to any random number that you like, but with some limitations. You will see when I am doing it. I will multiply these two. 3 into 8, 24. I'll put 3 zeros. I'll make it 24,000. Why did I multiply 3 and 8? So that later when I'm solving this, I'll get whole numbers. I will not get decimals. If I put 10,000, later I'll get decimals. So to avoid decimals, what we usually do, we take these coefficients and multiply. This is just a practice, not a rule or anything. Okay. Then put zeros. Why did I put zeros? Check this. If x is 0, y is going to be, oh, that's too many zeros. Okay, 2400 is enough. If x is 0, 2400 divided by y, because x is 0 means this part is 0. 8y equals 2400. Divide by 8, 300. If y is 0, x will be, y 0 means this is 0. Then 3x is 2400. Divide by 3, x will be 800. If you think this is too small, if you can't mark it here, I can take a bigger number, take multiples of this. Maybe I'll take, say, 2 times of this. If this becomes 2 times, that means I'm going to take 4800. Then answers also will become 2 times. Look at this carefully. If x is 0, 8y, 4800. Divide by 8, it will become 600. If y is 0, this part is 0. 3x is going to be 4800. Divide 1600. Okay. We can mark this. Let's mark it here. Let's take a different color. Okay. X is 0, y is 600. This is 1005. This, okay, 600 could be somewhere here. Then if y is 0, x is 1600. 1000, 1500, 1600 could be somewhere here. Then you connect these 2 points by a straight line. Connect these two by a straight line. What this straight line tells us is, if contribution is 4800, this is how the contribution line will look like. Suppose if the contribution increases, what will happen? This line will get shifted. How it will get shifted? Like this. Can you see the angle doesn't change? Angle doesn't change, but it gets shifted. It moves outwards. Why does it move outwards? Because when contribution increases, if this 4800 becomes, let's say, 10,000, the points will move up. So this graph will get shifted. And I need highest contribution. So what I will do, I will keep pushing this graph outwards and outwards. Right? Why am I pushing it outwards and outwards? Because I want the contribution to be highest. To get the highest contribution, the graph has to go as far as possible from the origin. Once again, see this. Let me erase the lines I have drawn now. First, I took a random number and drew the graph. Random number for what? for contribution. Then what do? I keep shifting this graph outwards and outwards. Shifting, what's the meaning of shifting? Angle should not change, it gets shifted like this. Like this. This line I will keep moving outwards. Until when can I move it? Until this line completely exits from the feasible region. Can you see? Now it is not completely exited. There is a small part inside the feasible region. So as long as there is an intersection between this line and the feasible region, there is solution. You can go further, go further, go further, go further. Right. At this point, it exits. Can you see? At this point, it exits. Where? At this point. So when it exits the feasible region, I find out what is the last point of contact. This is the last point of contact. Can you see? From the feasible region, the last point that was in contact with this line is point B. So let me put it this way. This line, we call it ISO line. Which one? The green lines I have drawn. ISO contribution lines. Draw the ISO contribution lines. Shift them outwards until it fully exits the feasible region. They can ask this in the exam to explain the last point of feasible region. Last point of feasible region that was in contact with, or that was intersecting with the ISO line is the optimum solution. So according to our graph, which one is the optimum solution? B is the optimum solution. According to our graph, I assume my graph is okay. If we have drawn according to the scale, by the looks of my graph, B is the optimum solution. So now we found out B is the optimum solution. Next problem is, okay, you found the point, but question is, what is the X value? What is the Y value? How much is X? How much is Y? So easy option to find that. There are two lines that intersect at point B. What are the constraints that intersect at point B? Can you see? Material goes through point B, and this demand of beta goes through point B. Labor doesn't go through point B. Labor is somewhere else. So take the two equations that go through point B. The two lines. What are the two lines that go through point B? One is material. Material, what was the formula? Material formula 1.5x plus 3y equals how much? 6,000. 1.5x plus 3y, 6,000. That is one of the lines that go through point B, 6,000. The other one is demand y 1,500. That was straightforward. Y 1,000 here, y less than or equal to 1,500. If you are talking about this line, then it's equal, y equal 1,500. Now we are talking about that line, right? The point B is on that line. So I can take equal. Same for material. Point B is on the material line. So you take equal. We need to solve them. This time solving is easy because Y answer is straightforward. Go substitute in the first one. 1.5x, 3 into 1,500, 6,000. This is 4,500. So 1.5x, subtract this 4,500 on the other side. 6,000 minus 4,500, 1,500. You have calculators, solve it. X equals, divide by 1.5, 1,000. My solving skills are faster, so I might just solve it without calculator. I suggest you guys use calculators and solve carefully. Good. We got the answers. X is 1000 and Y is 1500. So to get the optimum contribution, to get the optimum contribution or maximum contribution, let's say maximum, why optimum? To get the max contribution or profit, whichever. Alpha, that's the first product, right? Alpha, 1000 units, X is alpha. Beta, 1500 units should be produced. Should be produced. This is how you find the optimum solution using linear programming model. Once again, see this. First, we wrote the definitions, like what is going to be X, what is going to be Y, defining the variables. Then we draw the objective function. Most of your questions, or almost all the questions, your objective is maximizing contribution. And write a formula for contribution. $3, $8, so multiply by X and Y, 3X plus 8Y. Done. Then one by one constraints, I drew the equations, or we call them inequalities. So material inequality, labor inequality, demand and non-negativity, write them. After writing them, you don't have to draw them individually. This is not required. I did this to explain you guys. Once that is done, move to the common graph. So this graph, they never ask you to draw in a computer-based exam, but in turn they can give you the graph and ask you questions on it. So better way, you practice drawing the graph. So if they ask anything else from the graph, you can answer them. So draw the graph, draw the ISO line, that is the contribution line, shift the contribution line outwards. The last point of the feasible area that the ISO line passes is going to be the optimum point, point B. If you have a good scale, if you have done this on a graph sheet, we can just read it on the graph sheet itself. At point B, how much is Y, how much is X, we can read it. But here, I don't have such scale here, so I have to solve and find it. How do I solve it? Take the two equations that go through point B and solve them. So the two equations that go through point B are these two. One is material, other one is demand. Labor doesn't go through that point. Okay. Solve them, you get X and Y answer. Cool. What we have to do next is the analysis about shadow prices. In this case, how do we find shadow price? We will see in the next part of the video. Thank you.